Hi everyone, welcome to GemChem. Now today's video is on second order kinetics in the chemical kinetics part 3 video, and here we are seeing that differential and integrated form of the rate expression. Okay, now before starting, already 2 videos are uploaded in channel. You can watch it. I will give the link in the description box as well as the I button present above this video. Now if you are new to GemChem, do not forget to subscribe the channel and hit the bell icon for regular updates. Now let us start. In the second order reaction, we will deal with 2 cases, where first case is all about identical reactants or identical concentrations. That is, if the reactants are same, the concentration will be also same, whereas if the reactants are different, initial concentrations are taken to be the same. And this is the case 1, and the case 2 deals with different initial concentration. So if you see here, 2A gives P, A plus B gives P, whereas A plus B also gives P. But the concentration is different here in the second case, whereas first case the concentration is same. So if we try to write the rate equation for case 1, let us start doing it. So R comes to be as minus half dA by dt equals to K2 A to the power 2. And how to write it, we have already discussed in part 1 video and part 2 video. So you can watch it. I will here directly write the equations. How it came, it is necessary to understand from the introduction video, right? Now see, from here we can also write R equals to minus dA by dt and take the half in the right hand side and incorporate it in K2 concentration. So it will come to be as K2A square. Now we need to do the next step as integration. So integration will be from concentration A0 to concentration AT dA by A square, that is concentration of A to the power 2, right? So this will be A square concentration, which is equals to minus K2 integration 0 to T dt. Now on integrating, what we are going to get is this. See here, this will be 1 by A concentration at time t minus 1 by A concentration at time 0, which is equals to K2T. And from here, this is our main equation of rate for the second order, and from here we can get different equations which will help us to understand the rate more carefully and get different plots. So from here we can write AT is exactly equals to A0 by 1 plus K2T A0, right? Next part, from here we can also get this one, that is 1 by AT equals to 1 by A0 plus KT. We will take in this case this part as Y. This part temp T is that our time as X, and we are going to get a straight line with an intercept like this. And the intercept will be 1 by A concentration at time 0. This is our intercept, and our slope will be K2. This one will be our slope. And in this case, here we can plot this as Y and this temperature as X, and we will suddenly get like this. And this is our A and this is our T. Okay, we will see each graph separately in next slides. Now another one is that we can compare second order with first order. So for second order we can write AT by A0 equals to 1 by 1 plus K2T A concentration at time 0. This is for second order. And for first order we can write it as AT by A0 equals to minus K1T, and we have already seen this. So same initial rate, and we compare first and second order. Now from the equation we can understand that if we take this one and this one as y and this t and t, that is time, as x, this will decrease less rapidly. Decrease will be less rapid, whereas for first order case we have already seen the decrease is more rapid of the graph. So we will see the comparison graph in the next slides. Now we will see what is half-life for this case. Now we have already seen why we need half-life in order to detect the initial concentration when it is half, right? Now we will need to substitute AT with respect to A0 by 2, and we have already got the equation of second order. So A0 by 2 minus 1 by A0 equals to K2T. Ultimately what comes is this one, that is T half. Here we will take it T half equals to 1 by K2A0, and this is our half-life formula. Right. Now we will see the different graphs. So this is the rate graph with time. This is the concentration graph with time, which we have already derived using the equation. This is the ln plot. That is, we are taking the ln plot of A. So this will be slightly different in slope. Similarly, we have already seen this graph when 1 by A versus time is plotted, and this is the AT by A0 graph, which is decreasing but less rapidly. And if we compare first order and second order, this green and this pink shows the first order kinetics and decreases rapidly, whereas the blue and the orange shows second order kinetics and decreases rapidly. Now if you see, for the green one the K is very large, and also for the blue one that is present here is for second order kinetics, the K is very large. So if we compare this two, the first order decreases more rapidly rather than second order. Right. Now we will go to the case 2, and this is more important, right? Here we need two different concentrations. So we take A plus B giving us product, and at time equals to 0 we have for A, A0 concentration, for B, B0 concentration, and for P, no concentration. Whereas at time T we have A0 minus X concentration, and here we have X concentration, then B0 minus X. We are subtracting the concentration of the product from each. Now if we try to write the rate equation, it will be like this. R equals to minus dA by dt equals to minus dB by dt equals to dP by dt. And at t equals to t, we know dP becomes dx by dt, and K2 must be AT into BT, K2 AT BT for the rate equation, and here we just substitute the value of AT and BT. So it becomes K2 A0 minus X multiplied by B0 minus X, and the next step is our integration, right? So let us do the integration. It will be like this: integration from 0 to x, and it is dx A0 minus x and B0 minus x, right, and is equals to K2 integration t to 0 dt. And on further calculation, here this one, that is, if we take this particular and just remove it, Like here we have 1, right? So such a way it should be arranged that it is in the form of minus. So it will ultimately become like this. Here this integration gives us k to t equals to 1 by b0 minus a0 integration 0 to x 1 by concentration of a0 minus x minus of 1 by concentration of b0 minus x dx, right? Now 1 by something on integration will give us ln, so ultimately we will get like this, 1 by b0 minus a0 will give ln a0 by a0 minus x minus ln b0 by b0 minus x. And we know that b0 minus x is actually our this one, that is this, and this is our concentration at time t. So we can write it as A concentration at time t and this as B concentration at time t. Now we will rearrange the equation and get our desired equation so that we can easily plot the different graphs. Now for this case we are not going to plot any graph but show you the different equations which will help you to plot the graph. So ultimately on rearranging we will get ln bt by b0 by at by a0 equals to k2 b0 minus a0 time. Now see, this one, that is this one is your y and this time is your x and this particular thing is your slope. As we know, the straight line formula is y equals to mx plus c, and here the intercept, that is c, is equals to 0, and we will get a straight line from here. Also if we try to rearrange it like this, that is ln bt by at this side and we are taking a0 by b0 on the opposite side, then we will get like this, ln b0 by a0 plus k2 b0 minus a0 t, right? And in this case we can plot it like this. This is taken as y, this is taken as x. Now using this formula we can write it as, this is our intercept and this is our slope. So here ends the general discussion on the second order reaction, right? And the thing which is important here is that we have already dealt with first order, second order and zero order reactions, but we have not seen unit of K. So in the next video we will see a general expression for unit of K. Also we will see a general expression for rate and we will deal with few numericals. So stay tuned to this series and do not forget to subscribe the channel and hit the bell icon for regular updates and do like and comment.